Welcome all to another Project Euler episode. This is problem 17, number letter counts. If the numbers 1 to 5 are written out, 19 letters are used in total. If all the numbers from 1 to 1000 inclusive, meaning 1 and 1000, were written out in words, how many letters would be used? Do not count spaces or hyphens, and it uses traditional English. So this is a really fun one. As you can see, I have two classes set up, one called Word Converter, one called Project Euler 17. This is going to be a class with a static method, and this is going to have the meat of the program. Right here, let's just get started. From here we can see that we have a limit of 1000, and we're going to need a variable to count the words. So, final int limit equals 1000, int num words equals 0. Now we're going to have a loop that's going to loop from 1 to 1000. If I can type, I is less than or equal to limit I++. So down here, we're going to need to, this is going to have a convert method. And what this is going to do is convert a number to a word. So we're going to have a string variable to hold that word. String word equals word converter. Our method is going to be called convert. This is red because we didn't make the method yet, but this is what's going to happen. Next, we need to loop through this word and count the number of words in there, not including the spaces or hyphens. So, for int e equals 0, e is less than word.length, e++. So how are we going to not count the spaces or hyphens? What we're going to do is, alright, sorry, girlfriend texted me. What we're going to do is make them characters. So if word.charAt e does not equal a hyphen, and word.charAt e does not equal a space, then we want this to happen, right? Whatever the word is right here. It's going to take the character at space 0 and keep going up. And if it doesn't equal the ASCII value of a hyphen or the ASCII value and the ASCII value of a space, then it's going to do this loop right here, or do this body. And right here we're just going to do numWords++. See, that's pretty simple. And that's actually all we need to do in this class. So if you just want to write system.out.print, there we go. Now we get to the fun part. Over in here, since this is a static class, we're going to have all our fields are going to be static as well, all of our attributes. And we're going to make them private because that's just convention. What we're going to have is our units, which is going to be 1 through 19. And the reason is because there's just no other way to write it. That's literally the only reason we're doing this. String. I might fast forward this through. Okay, now that that's done, before we continue, I should say that this is probably not the most efficient method. I tailored this, tailored this program right for this solution. So it's not going to work with any numbers greater than 1000. So next we want to do the numbers, the tens places. So like 0, 10, 20, 30, 40, 50, 60. Except we don't need to do 0 or 10, but we're going to have a space in there anyway. So private final string tens equals space for 0, space for tens, and then we're just going to start off with 20. Okay, that's done. And a direct thing to note here, if you spell it wrong, it doesn't matter as long as you have the right number of words. The first time I did this problem, I actually spelled 18 wrong. I had E-I-G-G-T-E-E-N, and it was still the right answer because there was still the right number of letters in here. I just spelled it wrong. That's just a some food for thought. So next we want to get to our actual convert method, the meat. So static, and we're going to return a string actually. String convert. And what do we want to convert? We want to convert a int num. Okay. So I don't know why I wrote this in, but if n is less than 0, then we're going to return minus plus convert num. I even did it up here. What the heck? Okay, this is going to be a recursive method, by the way. I'm not sure how familiar you guys are with recursion, but this works really well for this problem. Trust me. So now that we have things less than 0, we want to do things less than 20. Anything less than 20, we can just return the units place. So if num is less than 20, return units at num. And the reason we can just do units at num I told you guys it'd be static. It does have to be static. The reason it being this is a static method, and if it references a variable, that variable also has to be static. So the reason we put a zeros place here is if say we have a 3 and we didn't have that 0 place, it goes 0, 1, 2, 3, and it'd return the 4, so we'd have to do num minus 1. But right here, including the 0 place, we have 0, 1, 2, 3, which it just makes things a lot easier, in my opinion. So next we want to do the hundreds place, and this is where things get a little fun. So right here we want to return a tens place, but how are we going to return tens place? How are we going to get that first digit? What we're going to do is we're going to call tens but divide num by 10. We're going to integer divide it by 10. And doing that will return that tens place to us. So hopefully seeing it will make more sense. This will return the tens place to us and return the right value. And if it's a tens place, or yeah, it will return the tens place. And right here, we want to see if it's a 0 or not. So n modulus 10 does not equal 0. I cannot type today. If it does not equal 0, we're going to return a hyphen because that's used in conventional English. There we go. So if it's not equal to 0, say it's 78. Between 70 and 8, there's a hyphen. If there's if it is 0, yeah, if it is 0, it will just return a blank space. Or nothing. Sorry, it's going to be nothing. So next, we want to do if num is less than 1,000, we will return units at num divided by 100 plus 100 plus n modulus 100 does not equal 0. Sometimes I think the world hates me. Units num 100 plus. Alright, we're just going to finish this out real quick. Plus convert n modulus 100. Okay, let's find out why the world hates us. That's why the world hates us. There we go. Sorry about that, guys. A thousand. I have a problem with calling this n. I'm not sure why. Don't yell at me. So that should work. So if everything's right here, we should get the right answer. The number of words are 21,224. Let's find out if that's right. 21,000. Ooh, that is not right. Hey guys, I found where I goofed up. I actually spelled something wrong. Speaking of the devil, like I said earlier in my video, except I added something. I had 40 with a U on it, and that actually boosts it up to 100. It boosts it up 100. So if you just get rid of that U in the number 40, everything should work out fine. It is 21,124 words. Thank you guys for watching. I'm sorry for my mistake. Please subscribe for the next Project Euler video. And yeah, thank you for watching.